Let's solve one more geometric power series here. This time we have 1 over x to the 4th plus 1. However, we really only have this as our technique, so how are we going to do this? What we're going to do is we're going to take a multi-step approach to kind of incrementally get there. The first thing we want to do is figure out how would we get a power series for something like f of x 1 over 1 plus x. How would we get a power series for 1 over 1 plus x? I've got something for like 1 over 1 minus x, but I don't have a 1 over 1 plus x. So the simple thing to do is just say 1 minus negative x. Now I have something where my a is 1 and my r is negative x. So then I can say, alright, well, that power series is n equals 0 to infinity of 1 times negative x to the n. Well, at this point then, that is, and probably easier way to write that is negative 1 to the n, x to the n. So that's my power series for 1 over 1 plus x. But I don't have 1 over 1 plus x. I have 1 over x to the 4th plus 1. So to do that, what we have to do is we have to do a little more algebraic manipulation, but not really. Notice that f of x to the 4th is 1 over 1 plus x to the 4th, right? Which is just the same thing as x to the 4th plus, or 1 over x to the 4th plus 1. So now I have this. Well, I know that f of x is equal to that. So f of x is also you just plug in x to the 4th, which we could then rewrite as n equals 0 to infinity, negative 1 to the n x to the 4n, if you wanted to. This is probably fine. And the reason why it's more helpful is because this is going to help us with the interval of convergence. Now we know that this is centered at 0, so we don't have to worry about any sort of weird things there. We just have to say, all right, x to the 4th has to be less than 1. So we can write this as a double inequality if we wanted to. But notice that x to the 4th is never negative. So we don't have to worry about the negative case. But we kind of do. What do I mean by that? Well, x to the 4th is never negative, but that doesn't mean that x is never negative. So ultimately, we get that this is true because if I plug in negative 1 to the 4th, if it's a little greater than negative 1, it's still less than positive 1 when you take it to the 4th power. The other way to do this is kind of do like that the square root thing, where you say, okay, well, this is true and that's true. You could do something like, x to the 4th minus 1 is less than 0. So x to the squared plus 1, x squared minus 1 is less than 0, which is to say x squared plus 1 times x plus 1, x minus 1 is less than 0. And if you do that, you say, okay, well, this is always positive. This is negative 1, this is positive 1, where these things are equal to 0, so you split the number line into positive 1, negative 1, and then you test each interval. You say, all right, if x is negative 2, I get negative 1, negative 3, that's not less than 0. If x is 0, I get 1, 1, negative 1, so that is less than 0. If x is positive 2, I get 5, 3, 1, that's not less than 0. So this is the only interval. So that you could do that way if you really wanted to. But the easiest way is to recognize that if the magnitude's less than 1, and this thing sort of like acts like a squared function, then I can go all the way to negative 1, or just shy of it, and all the way just shy of positive 1. And so your interval of convergence is negative 1.